A very good morning to all of you children. This is Aisha and we are continuing with our first chapter of chemistry, that is metals and nonmetals. In my previous video, I dealt with the physical properties of metals and nonmetals. We differentiated the physical properties of metals and nonmetals under specific headings. And today, let us learn about the chemical properties of metals and nonmetals. In order to understand their reaction with different substances, you should first know about the chemical nature of metals and nonmetals. So the first point here, you can see that metals are electropositive in nature. What do you mean by electropositivity now? So as you know children, that atom consists of 3 subatomic particles. They are nothing but, what are they children? They are nothing but protons, neutrons and electrons. These electrons revolve around a positively charged nucleus that contains neutrons and protons. Now, these atoms, in order to become more stable, they tend to either gain electrons or lose electrons. So when an atom loses an electron, it gets a positive charge. I repeat, when an atom loses electron, it gains a positive charge. So in contrast, when an atom gains an electron, it becomes negatively charged. I'll explain this with a simple example. Let us consider that there is an atom which contains 4 electrons and 4 protons. Okay, 5 electrons and 5 protons. Now, for instance, if it loses one electron, we all know that electrons are negatively charged, right? We all know that electrons are negatively charged. Now, if it loses one electron, one negative charge is lost. So let us see what is the net charge now present in the atom. So for this you should be knowing that in an atom there are equal number of electrons and protons present. So 5 electrons and 5 protons. From this, if one electron is lost, let us see the net charge now that is present. So let us cancel 1 negative, 1 positive. In the similar manner, 1 negative, 1 positive, and you can see that 1 positive charge is left over. That is the net charge now present on the atom. Did you understand children? Now let us see another example where an atom contains 3 electrons and 3 protons. Now if an atom gains an electron, you will have an extra negative charge. You can see that there are 3 negative charges and 3 positive charges. They nullify each other, and what is the net charge now? Extra charge that is present? Negative. So in this case, what is happening? When the electron is lost, you are getting which charge here? Positive charge. And when an electron is gained, you are getting a net negative charge. So what is electropositivity now? It is the tendency of an atom to lose electron. If the electron is lost, what is the net charge that we are getting here? Positive. So it's the tendency of any atom to lose electron and form a positively charged ion. It's called as electropositivity. So as you can see here, metals are electropositive in nature. So in the similar manner, electronegativity. We have seen here that if an atom gains an electron, it gets a net negative charge. So this tendency of some atoms to gain an electron and become negatively charged, it's called as electronegativity. One more thing you have to learn here children, that The positively charged ions are called as cations. What are they called, children? Cations. And the negatively charged ions are called as anions. So, what are cations? These are positively charged ions. And what are anions? These are negatively charged ions. So, it is clear from it that metals are electropositive. That means what? They lose electrons and gain a net positive charge. That means they form cations by losing electrons. Now it depends on the atom whether they lose 1, 2 or 3 electrons. So if you can see here, sodium, it loses 1 electron, so that 1 positive charge it gets. Magnesium, on the other hand, it has a tendency to lose 2 electrons. So it gets net 2 positive charges. So these are nothing but cations that are formed. On the other hand, if you talk about non-metals, it depends on the atom whether it gains 1 electrons or 2 electrons or 3 electrons. Like for example here, chlorine, it can gain 1 electron to become stable. So chlorine gets 1 additional negative charge. So anions, non-metals form anions by gaining 1, 2 or 3 electrons. Did you understand this, children? Let's go for the next one. Reaction with water. What happens when metals react with water? You can see here, this is the general equation of metals reacting with water. Capital M stands for metals here. Metal, when it reacts with water, it forms metal hydroxide and hydrogen gas is released. So it's a general reaction showing the reactivity of metals with water. Metals react with water to form either metal hydroxide or metal oxide, and hydrogen gas is released out. Some examples are sodium reacts with water to form sodium hydroxide and hydrogen gas is released out. In the similar manner, magnesium, potassium, magnesium and zinc also react with water. Actually, sodium and potassium, they react very vigorously with even cold water and hydrogen gas is released out. Actually, this hydrogen gas, it catches fire because of the enormous heat that is produced due to this reaction. Because sodium and potassium are the most reactive metals. So they react vigorously with water and form sodium hydroxides. Whereas magnesium and zinc are moderately reactive, not so reactive as sodium and potassium. They react with water and form magnesium oxide and zinc oxide. Hope you understood the difference here. Sodium and potassium form metal hydroxide, whereas magnesium and zinc form metal oxide. But what is common? Hydrogen gas release is common here. Speaking about non-metals, they do not react with water. Non-metals cannot react with water. Reaction with oxygen. This is the general reaction again. What happens when a metal reacts with oxygen? Metals, when they react with oxygen, they form metal oxide. What do they form? Metal oxide. This is the general reaction. So in place of metal, you can keep any names, any examples of the metals. Like for example, again sodium and potassium, which are very reactive metals, they react readily with oxygen and form sodium oxide and potassium oxide respectively. Magnesium also reacts with oxygen to form magnesium oxide. Magnesium ribbon, when it is burnt in the presence of oxygen, it gives a flash of very bright and white flashes of light. It burns with white flashlight and forms ash, which is composed of magnesium oxide. Coming to non-metals, non-metals, when they react with oxygen, they form non-metal oxide. Again, same like metal oxides, they form non-metal oxides. Can you name some non-metals, children? Yes, carbon, sulfur, nitrogen. Here, I have given these examples. When they react with oxygen, they form carbon dioxide, sulfur dioxide, and nitrogen oxide. Nitrogen dioxide also can be formed. Most of the metal oxides that are formed when metals react with oxygen, metal oxides are formed, right? Now, most of the metal oxides are insoluble in water. They don't dissolve in water. But there are few examples of metals like metal oxides like sodium oxide, potassium oxide, calcium oxide and magnesium oxide, which can dissolve in water and form alkalis or metal hydroxides. So these metal oxides, they form alkalis or metal hydroxides when dissolved in water. So the soluble metal oxides, they dissolve in water forming alkalis. Examples are magnesium oxide. When it reacts or dissolves in water, it forms magnesium hydroxide. Speaking about its chemical nature, it is basic in nature. So what will happen to the red litmus solution, children? So the red litmus paper or solution will turn to blue, indicating the basic nature of alkalis or metal hydroxides. I told you that magnesium, it burns in air and produces ash-like substance which is called as magnesium oxide. So if you take that ash and dissolve it in water, it forms magnesium hydroxide. Just dissolve little of that ash formed in water and check for yourself its basicity or basic nature by dipping red litmus paper. When you dip a red litmus paper in that solution, you'll see that it turns to blue, indicating the basic nature of magnesium hydroxide. Similarly, calcium oxide forms calcium hydroxide. Sodium oxide forms sodium hydroxide. If you test all these things with litmus or any other acid-base indicator, you will see that they are all basic in nature. So, in a nutshell, we can say that metal oxides are basic in nature. Very, very important concept here. Metal oxides are basic in nature. Let us see what will happen when a non-metal oxide is dissolved in water. You can see that when a non-metal oxide is dissolved in water, acids are formed. So what are the examples of non-metal oxides that we saw just now? Carbon dioxide and sulfur dioxide. When they are dissolved in water, carbonic acid is formed. Can you see what is the formula of carbonic acid? H2CO3. Carbon dioxide, when it dissolves in water, it forms carbonic acid. In the similar manner, sulfur dioxide, when it dissolves in water, it forms sulfurous acid. It is not sulfuric acid, children. Sulfuric acid is formed when SO3 dissolves in water. Now this forms H2SO4, which is sulfuric acid. This is sulfurous acid. So it's in the name itself. It's acidic in nature. So how can you prove that these are acidic in nature? Just dip a blue litmus paper in these solutions. You will see a color change from blue to red, indicating the acidic nature of these compounds that are formed. So that's all for today, children. Tomorrow or in my next video, we shall be learning about the reactions of metals and nonmetals with salt solutions and reactions of metals and nonmetals with acids. Thank you.